Okay, so as you're kind of finishing up there, let's kind of start talking through this stuff. So what we're going to talk about today is something called trig functions. The main trig functions we're going to focus on for now. There's a few others as well, but we're going to focus on something called sine, cosine, and tangent. You've probably seen those before on like Iowa assessments or that kind of thing. So hopefully I can kind of explain a little bit of what they are. They're buttons on your calculator as well, which I'll kind of show you how to use those. What we use these for is when we're dealing with triangles, specifically what we're going to talk about today is dealing with right triangles, how we can use this. And basically what you can do is you can use like an angle and a side to find another side, or you can use two sides to find an angle. So it's kind of the Pythagorean theorem stuff where we did like a squared plus b squared equals c squared. That helps us figure out like just the side lengths or if it's a right triangle or not. But this stuff is going to help us more with like finding angles from some things with that, okay? So what we need to know here, like I said, this SOHCAHTOA stuff is what it's going to be called, is only going to work when we have right triangles. It's going to have an acute angle in here. The acute angle could either be this one or this one. In this case, they've got this one marked. This symbol here, it's kind of like a zero, so sometimes I'll write it like that as well. So this stands for theta is what that's called. It's basically just like a variable that they use for angle. Sometimes it's a Greek letter, but that just represents that angle. So if we're talking about this angle specifically, we need to know information about the sides. We know opposite the 90-degree angle is always our hypotenuse, right? So that's important. Then these other two sides are also important, and they're based on where the angle is. So if this is the angle we're talking about, the side that is touching it is called the adjacent side. The side that is not touching it is called the opposite side. Okay, so if our angle is here, this is adjacent, this is opposite. Say I moved my theta up here and I wasn't concerned about that angle now and I was looking at this one, this side would switch to adjacent, this side would switch to opposite. Okay, so pending what angle you're talking about, always the one across from it is opposite, the one touching it is adjacent, and then the one opposite the 90 is always the hypotenuse. Okay, so those are going to be important because what we're going to do is we're going to take those pieces of information and we're going to put them into these kind of formulas here. So we've got sine of theta, cosine of theta, and tangent of theta. So the abbreviation for sine of theta, or sine, is just sin. So sine of theta is always equal to the length of the leg of the opposite over the length of the hypotenuse. Okay, so I would maybe highlight here sine and then opposite over hypotenuse. For cosine, cosine COS is the abbreviation for that. That is always the length of the leg of the adjacent one, so the one next to it, over the hypotenuse. And then tangent, they use tan for that. Tangent is always the length of the hypotenuse over the or not the hypotenuse, the opposite, so length of the leg of the opposite over the length of the leg of the adjacent, okay? Now that's a lot to remember, so what they do is they use this phrase to help you remember this. So if you've ever heard someone say SOHCAHTOA before, that's just a way of remembering what goes with what here. So like so stands for the one with the sine, right? So sine is opposite over hypotenuse, so that's why they have like SOH, because opposite and hypotenuse. Ca is cosine because the C goes with that, and then that's adjacent over hypotenuse, so the ca is for the cosine, and then tangent is the TOA, so tan is the T, and then opposite over adjacent is that one. So if you say something with like SOHCAHTOA, people know you're talking about this right triangle stuff with the trig functions, okay? Okay, so I'll let you write down this next example here, and then we'll talk through that. Like I said, I didn't make packets up this time because I was trying to just kind of figure out this stuff on the fly, so just sketch that out there, and then we'll solve this one, and then, like I said, there's just a couple more examples we'll do together. Okay, so let's take a look at this one. So it says, what is the sine of A? Okay, so first thing we're looking at here, so A is just this angle here. So we got, three angles there, A, B, C. A is the one we're looking at. Look at that one right in there. So what I want to think here is if I want to find the sine of something, I'm thinking about my SOHCAHTOA. So sine stands for opposite over hypotenuse. So what I need to establish here is based on this angle, which number is the opposite and which number is the hypotenuse. So like here, my sine of A is going to be equal to our opposite over hypotenuse. And then I just figure out what those are. So what do you think this, well, let's start with hypotenuse because usually that's the easiest one. Which number there is the hypotenuse? The 4.9. So here, if we're doing sine of A, bottom there would be 4.9 because that's our hypotenuse. Okay, and then now we're thinking the side opposite. So what is opposite the A? The 2.8 would be, yeah, because this one would be touching it, so that would be the adjacent one, so this would be the opposite one. So we just have 2.8 there. And then really in this case, you could either leave it like that, because they don't need us to find any angle measures or anything, they just wanted the sine of it. So you could either leave it like that, or if you put it in your calculator and reduce it as a fraction, it's also the same as 4 out of 7. Either of those would be fine. You could also take it down to a decimal too. It's not a very nice decimal, but if it just says, hey, find the sine of that, you can just leave it as that fraction, okay? It's kind of like, or if they said like the ratio of sine or something, this would be like a ratio as a fraction. Does that kind of make sense? Okay. Let's try some other ones here. Okay, so let's take a look at these ones. So in these ones, they don't tell us, if we're using sine, cosine, tangent, whatever, we've got to figure that out. And we're supposed to find the missing side length. So in this case, the one they're making us look for is like the x here. And then whatever answer we get for that, they want us to round to the nearest tenth. Okay, so if this is the angle we've got right there of 55, what we've got to be thinking here is we're doing one of those things, sine, cosine, or tangent, and we're basing it on the two sides that we either have or we're looking for. So like here, again, the obvious one to pick out is always the hypotenuse, because wouldn't 14 have to be the hypotenuse? Because it's opposite the 90, yeah, so we know we're either dealing with the SO or the CA, because those both have the H in it, right? So tangent's out. So now we're thinking, okay, well, if I've got this angle here and this side, do you think that this side is opposite the angle or adjacent to the angle? Opposite it, right? So if I've got an opposite and a hypotenuse, wouldn't that be my SO? So I would want to use sine. So that's my first thing. So this would be my hypotenuse. This one would be opposite. So I know I need to use my sine function. Then I'm thinking, okay, well, my angle here is 55. So what we're going to do is we're going to do sine of 55 degrees, because this is where our angle measure goes with the sine, is equal to, and then our setup here, so sine is so opposite over hypotenuse. So our opposite is the x over our hypotenuse, which is 14. And then what we need to do there is we need to solve that equation for x. Okay, so like here, if it's x over 14, that's like division, right? How do I get rid of divide by 14? Multiply, just like we've always done, right? So multiply both sides by 14. So that makes it go away from there. We'll just have x. And then over here, what we would have is just 14 times the sine of 55 degrees. And then this is where I would use my calculator to figure out what this is. So everyone should, before we get started here, I don't know what the default setting is, but everyone make sure that they, so if you're using one of these calculators, what you need to do before you start doing any of these, you need to go to this button here that says mode, hit that, and then mine's set for radians right now, but we need to make sure that this is in degrees. We will do stuff with radians next year when we do more stuff with trig functions if you take trig, but for now we're just going to put everything in degrees, so you need to make sure that this, on the third one down, is highlighted on degree. If it's not, you just go over to it, hit enter, and just make sure it's highlighted on degrees. If it's on radians, you're going to get a different answer. Okay? Everybody follow that? So make sure, if you, especially if you use like one of my calculators, make sure it's in degrees first, because if you use radians, you're not going to get the right answer. Okay, so then we'll get out of that, so you just go second and quit. And then if I'm typing this in, so I got 14 times sine of 55, so I just do 14 times, and then the sine button is here above like the comma, so I just hit sine 55, hit enter, and it should kick out my number there. Okay, so then my x would be approximately equal to, and they want us to round to the nearest tenth, so that would be one position behind the decimal, so the 6 would round that 4 up, so approximately 11.5. So that would be the missing side length there. And you can always think too, if I'm doing this, hypotenuse always has to be the bigger side, right? So 14, well 14 is bigger than 11.5, so that seems like a reasonable answer. Okay, so let's try this next one here. So same concept. We got an x here, we got the 19, and then we've got that 39. So if we're thinking through our stuff here, and we've got 39 here, we got to be thinking, okay, well what information do we have, or what information are we looking for? So I got that 39. Hypotenuse, do we have the hypotenuse? No, but it is one of the things we're looking for, right? It's not the blank one. We don't know it, but it is one of the things we need. So we got a hypotenuse. What's this number represent? Is it opposite or adjacent? Adjacent, right? Because it's touching the or it's a side touching that angle there. So this would be adjacent. So now I'm thinking through my things. So I'm like, okay, well, adjacent and hypotenuse, that would match with the cosine stuff, right? Because that would be ca. So it would be cosine of something, so in our case cosine of 39 degrees is equal to, and then it'll be our adjacent over our hypotenuse, so our adjacent here is the 19 over our hypotenuse, which is x. And then this one's a little bit trickier to solve. I don't know if you guys remember what to do when you've got your variable on the bottom. What you have to do is you actually have to work to get that to the top to be able to solve it. So if this x is on the bottom, what we have to do is we actually multiply by x on each side first to get it off the bottom there. So then we're left with 19 on that side, and then this side would be equal to x times our cosine of 39 degrees. And then we got to keep going a little bit further than this because we still have to get that x by itself. So this is just like multiply. So to get rid of multiply by that cosine of 39, we're going to divide by cosine of 39 degrees on each side, because then those will go away there and you're just left with your x is equal to, and then we just do 19 divided by cosine of 39, and we just do that on our calculator then. So you would just do it out, you would just do like 19 divided by, do your cosine, oops, then cosine of 39, hit enter, and that should kick out your number there. So I get mine as x is approximately 4, so the 4 would stay, so 24.4 as my side length. And again, you could kind of double check there because what we were finding was the hypotenuse. 24.4 is bigger than 19, so that makes sense. Okay, and then I'll just let you guys sketch out this last one here. We'll do that one, and then I'll let you guys work on some practice stuff. Okay, so let's take a look at this last one here. So same thing, we got to just start by, looking at our angle. So we got that 60 in there, that's the angle we're talking about. And then we got to see how the side lengths relate to that angle. In this case, typically we look for hypotenuse first, right? So here, if that's our 90, do we know anything or need anything with the hypotenuse? No. So if we don't need a hypotenuse at all, or we're not looking for it or needing it or whatever, that means we know we have to be tangent, right? Because tangent is the TOA, and that was the only one that didn't have hypotenuse. So TOA is opposite over adjacent. So here we're thinking, okay, well, it's got to be tangent of something, or tangent of 60. Throw that in there. Now we got to think about what's opposite and what's adjacent. Which of those things do you think is the opposite one? It's the x, because opposite is always the one that doesn't touch it, right? So if this is our angle, the one that doesn't touch it would be this guy down here, right? So this would have to be our opposite. And then the one that does touch it is the 3 square roots of 3, so that one would be our adjacent one. Okay, so then TOA, when we set this up, would be opposite over adjacent, so our opposite is x. Our adjacent is 3 square roots of 3, and we've been working with stuff like that, so that shouldn't throw us off at all, right? So then with this one, if we're trying to get the x by itself, well, let's divide by that number, so to get rid of divide by it, multiply by this 3 square roots of 3 on each side. So then that would be gone, gone. So x would equal whatever 3 times the square root of 3 is, times tangent of 60 degrees. And then again, we would just use our calculator to figure that out. So you can just do 3, do your square root of 3, and then just times your tangent of 60 degrees. Kick that out, and it actually kicks out an even 9, which seems kind of weird, but what's going to happen when we do more studying with this stuff, there's special roots and stuff that match up with different things with the sine, cosine, and tangent. It's part of a unit circle. When we get to unit circle stuff next year, we'll talk more about that, but there's a reason that it comes out to be a perfect 9 there. Okay, but we'll worry more about that next year, okay? All right, so that's all we're doing with that. So I'm going to get you guys a worksheet here.